the concept of derangements. Before I get into the mathematics involved, let us solve a bunch of basic questions around this concept. Please pause the video and try solving it yourself. 4 letters, let's say A, B, C, and D, and 4 envelopes. Let's call them A, B, C, and D, lowercase. First question, all letters go into right envelopes. Of course, there is only one case. The answer here is 1. Second question, 3 letters go into right envelopes. Imagine, is that practically possible? If one letter, say A, goes into wrong envelope, let's say it goes into the envelope of B, then the letter B is also bound to go into some wrong envelope, A, C, or D. Therefore, this case is not possible. The answer is 0 here. Next case, 2 letters go into right envelopes. How do we solve this? First of all, we must select which 2 letters go into the right envelopes. So out of these 4 letters, A, B, C, and D, 2 can be selected in 4 C2 ways. That is 6. Now 2 letters are left. One letter has one choice of envelope, the wrong choice, and that other letter also has only one choice, the wrong choice. So the answer is 6 times 1 times 1. The answer here is 6. Next case, 1 letter goes into the right envelope. Once again, 4C1. 1 letter out of 4 that goes into the right envelope can be selected in 4C1 or 4 ways. Now imagine you have 4 letters, A, B, C, and D. 1 letter has been selected for getting into the right envelope. Let's say A goes into the right envelope. Of course, it could be A, B, C, or D. That's why 4 cases. Now 3 letters are left. B has 2 choices, and then C and D would have 1 choice each. So total number of cases is 4 times 2 times 1 times 1. The answer is 8. Next, no letter goes into right envelope. This is the case of perfect derangement. Doing this manually will be a bit complex. Therefore, some mathematics is involved. This question is indirectly asking you the number of derangements for 4 objects. Let's understand this concept. Derangement is an arrangement of elements that leaves no element in its original or correct position. For example, in the last case here, no letter goes into the right envelope. 4 elements and none of the 4 go into the correct position. The total number of possible derangements for a set with n elements is, it's called dn when there are n elements. Please look at this formula. See, the first 2 elements basically add up to 0. So you can very well just eliminate this. And then 1 by 2 factorial. Now the number involved is odd, so the sign becomes negative. The number involved in the denominator is even. The sign becomes positive, and ultimately the series ends with n factorial. And once again, if n is even, the sign would be positive, otherwise negative. Now here is a grid for values. Imagine if there's only one object. It cannot be deranged. Therefore, 0 ways of deranging one object. If there are 2 objects, imagine A, B, A, B, there is only one way of derangement, that they take each other's position. So only one way. D3 is 2. So imagine in this particular question, what happened? Out of 4 letters, 1 went into the correct envelope, and the other 3, imagine, could be arranged in 2 times 1 times 1 equals 2 ways. So after 1 letter went into the correct envelope, the other 3 could be deranged in just 2 ways. So if you know that D3 is 2, you can just directly apply this and save some time. D4 is 9. D5, similarly, is 44. And frankly, I have never seen a value greater than 5 in any question ever. If you can just remember some of these, it may just end up saving some time. Now let's look at the last question on the last slide. This one. So this is simply D4. As you just saw, D4 is 9. So the answer for the last question here is 9. This particular value. Now let's solve a bunch of questions. Please pause the video and solve these yourself. First question is the same. It's simply the value of D4, which is 9. The answer is 9 here. Look at the second question. Only 1 letter goes into right envelope. So first, select the right letter. This can be done in 5C1 ways. That is 5. Now the remaining 4 can be arranged, rather deranged, in D4 ways. And therefore, 5 times D4 is the answer. D4 is 9, so the answer is 5 times 9 equals 45. Look at the last question here. There are 6 letters. 2 go into the right envelope. So out of 6, 2 can be selected in 6C2, that is 15 ways. The remaining 4 can be deranged in D4 ways. Therefore, the answer is 15 times D4. D4 is 9. The answer is 15 times 9 equals 135. This was the concept, friends. GMAT shots are deliberately kept brief. For an elaborate explanation, please watch the Stage 1 conceptual videos in our program. Thanks for watching.